Ghana Narguriti. This is a project that predicts the electrical energy output of a combined the gas and steam cycle power plant using Google AutoML machine learning. So the approach that we have taken for this continuous numerical value prediction was a regression task. Um, the data set contained the temperature. These are the features that were provided, the temperature, vacuum, pressure, and the humidity. And since Google AutoML has the capability of running multiple regressive cycles and apply the most optimum algorithm, and in this case, it selected the boosted trees as the best model for the data set. The number of trees that it spun was like 250 to 400 based on the model, which is like two models that we used, and the tree depth is 3 and 6, and the lasso and the ridge regularization that it automatically applied to avoid overfitting. These are the data features. About 10,000 hourly observations were included in the data set, and AutoML actually has an inbuilt feature to do data splitting and internally does the cross validation. There were two models that we ran, and comparing these two models, it basically is the same algorithm that was applied with two different optimizations, the RMSE and the MAE. In these cases, the AutoML automatically had applied or selected, finalized the the depth and the number of trees and the lasso and ridge regularization based on the optimization for RMSE versus the MAE. These are the two comparisons recordings for the two different optimizations that we have used. The model 1 was RMSE and the model 2 is MAE. And as you can see, the MAE, it measures how far the predictions are from actual values. The RMSE, the root mean squared, is penalizing the large errors. And the root squared, it measures how well the model explains the variance. So you can see that this should be closer to 1, and in both cases, this is closer to 1, which makes this either one of these models pretty stable. But based on the readings we can conclude that the MAE is the better model of the two. However, with AutoML, I had few challenges and limitations where I could not test out or create a training model that to remove one of the features. And so you have a high MAP, which is like 52.3, which means that it has relative errors existing in that because of high correlation. Let me quickly go over the interface where you can see that there are two models that we created. These are the two models, and we'll quickly go over this. All right, so these are the two projects. Project 1, which is the RMSE optimized, has um, has these features, has these readings, and the feature importance is automatically provided by AutoML. So there's many advantages uh, with using the AutoML because it handles most of the manual tuning that we would have to do, which is for the hyperparametering and hyperparameter tuning. We would not have to really do that all manually. The tool basically takes care of it. But there's a big learning curve of how to use the tool itself. So this is my presentation. Hope this was clear. Thank you.